In this instructional video, we will be discussing in great detail the correct procedure for splicing flexible PVC water stop. For those with little or no experience installing PVC water stop, the following information will be very insightful. For the experienced installer, we hope to reinforce proper practices to maximize the performance of water stops and the structures you build. Water stop splicing is required wherever water stops unite, change direction, or intersect, and is extremely critical to ensure a quality installation. While millions of feet of water stop are installed in concrete structures of all kinds around the world, improper splicing is the usual suspect when a water stop fails to perform. This is usually the result of untrained installers. This demonstration is designed to shed light on the unknown and eliminate misinformation, ensuring green streak PVC water stops are installed in a manner that will result in a watertight structure every time. When connecting two or more lengths of water stop at a single location, the adjoining ends must be connected to provide a continuous barrier without interruption or break. These water stop connections must be spliced together by means of heat welding with a suitable water stop welding iron. This is the only acceptable way to splice PVC water stop. Some examples of unacceptable methods commonly observed are butting water stops end to end without any means to physically connect or splice them together, overlapping the ends of the water stop, whether welded or not welded, the use of any type of epoxy, adhesive, or solvents to join two or more lengths of water stop together, the use of screws, nails, or mechanical fasteners to connect water stops, the use of a direct flame such as a handheld torch or similar device. Green streak welding irons can be purchased from your source for green streak water stops and are available in two sizes, simply called a large and a small iron. The large iron is much more versatile as it provides a much larger surface to melt the water stop. The small welding iron is often too small to weld some of the larger water stops such as tear web, labyrinth, retrofit styles, or profiles with large center bulbs. The entire profile of the water stop should be able to interface with the surface of the iron. There are several other tools and materials that will assist in making acceptable heat welds. Green Streak standard welding irons are powered by a common 110 volt 8 amp AC power source. Special irons are available upon request for 240 volt power sources, common with projects outside North America. When using an extension cord, try to limit the extension to 100 feet or less. A pair of gloves should be used when handling any welding iron and welded water stops. Welding iron temperatures can reach in excess of 500 degrees Fahrenheit, so use extreme caution when handling an iron, even if the iron is not plugged in. It can take about 30 minutes for a hot iron to cool down. You should also keep a rag nearby that can be used to wipe away excess melted PVC off of the face of the welding iron after each weld is made. Though not required, a digital pyrometer can be used to identify the temperature of the welding iron. Building a simple welding jig is recommended and can provide a flat surface and guide that will stabilize the iron during the welding procedure. You will also need to keep the proper tools nearby for cutting the water stop. When available, a compound miter saw is the best means for cutting the water stop precisely. It makes straight cuts quickly and easily, but more importantly, makes extremely accurate miter cuts for water stop intersections. Inaccurate miter cuts will result in misalignment of the water stop pieces used to make the fabrication. The availability of a compound miter saw at a job site is sometimes unrealistic. The next best alternative is a circular handsaw. More care has to be taken when mitering water stop with the circular handsaw, however, since the accuracy of the cut is in the hands of the saw operator. The water stop must be carefully marked where the cut should be made, and the operator must closely cut along the mark. For straight cuts, a sharp utility knife is a less desirable option, as it takes much more time and is somewhat difficult to maintain a straight, accurate cut. It is imperative that the ends of the water stop to be welded or cut perfectly straight. A utility knife should not be used to make mitered cuts for water stop intersections. So now that you have the proper equipment to make water stop welds, let's take a look at how to actually use the welding iron correctly. The first thing you want to do each day when you arrive at the job site is to plug the iron into a power source. It can take up to an hour for the iron to reach the appropriate temperature for welding, so make sure you allow sufficient time to heat the iron. If it is possible to work in an area protected from wind, do so. It will be easier to maintain consistent temperature of the iron and welded material. If working indoors, proper ventilation is required. PVC water stop must be heat welded at approximately 360 to 380 degrees Fahrenheit, so anyone assisting in welding the water stop should wear protective gloves. There is no power switch in the iron. Once you plug the iron into a power source, it will start to heat up very slowly. You can adjust the temperature of the iron with the appropriately labeled temperature dial. It is common practice to start with the iron on the hottest setting and then turn it down if you find that it is too hot. If you do not have a digital pyrometer available, you will have to use good judgment to determine whether the iron has heated to the appropriate temperature. Simply take a piece of PVC water stop and hold it directly on the face of the iron. If it appears that the water stop is melting within 20 or 30 seconds, the iron should be hot enough for welding. Green streak PVC water stop should not significantly darken when melted. If it has, it's an indication the welding iron is too hot and the water stop has been charred. Once the iron is at the correct temperature, you're ready to start welding. Correct water stop welding is primarily about technique. Once you have learned the correct technique, making consistent, high-quality butt welds is quite simple. Splicing water stop typically requires at least 2 people, one person to hold the welding iron and one person to hold the ends of the water stop against the face of the iron. For large or asymmetrical water stop profiles, it may even require 3 people, with a person to hold each end of the water stop to the iron. When butt welding 2 straight lengths of water stop, you must melt the adjoining pieces simultaneously. Melted PVC cools very quickly, and working time is limited to a few seconds before the material returns to a solid, preventing a proper bond. When melting the water stop, you want no less than 1/8 inch melted bead of PVC around the entire perimeter of the water stop at the interface with the welding iron. This ensures that you will have a good bond throughout the entire width and thickness of the water stop. In order to achieve an adequate bead, it is important to apply sufficient and uniform pressure between the entire water stop cross-section and the surface of the iron. This will also prevent unmelted spots along the face of the water stop. Once sufficient melt is achieved, remove the adjoining ends simultaneously from the iron with a quick jerking motion, which ensures that the melted PVC remains on the end of the water stops and not on the face of the iron. Once you remove the water stop from the iron, quickly press the 2 melted ends together as fast as possible. Although pressing the water stop ends back together has to happen quickly, care must be taken to ensure that the proper alignment is achieved at the weld. The water stop ribs, dumbbells, and/or center bulb should maintain continuity and alignment at the splice. Signs of an inadequate weld include tensile strength less than 80% of the parent section, misalignment of center bulb, ribs, and end bulbs, bond failure at joint deeper than 1/16 inch or 15% of the material water stop thickness, misalignment which reduces the water stop cross-section greater than 15%, visible porosity in the weld, visible signs of splice separation when a cooled splice is bent at a sharp angle, charred or burnt material, and an overlapped weld. Each day when the last water stop weld is made, unplug the iron and allow it to properly cool on its own. Do not spray water on the iron or drop it in water to cool it down faster. It is a good idea to have the same individuals performing water stop welding throughout the entire project. It is difficult to learn the correct technique and maintain quality and consistency in water stop splices when many different individuals are performing this function. It is also a good practice to perform a destructive sample weld at the beginning of each day to ensure that the proper technique is being used and that the welding iron is working properly. This can be done simply by making a straight butt weld and then cutting the water stop splice along the axis of the water stops at multiple locations to expose the inside of the weld. Other than the melted flashing of PVC at the splice, the center of the water stop weld should look the same as the unmelted cross-section if the weld is sufficient. No porosity and no difference in color or consistency. Keep in mind that destructive testing may only be performed on sample welds. It should not be performed on water stop welds that are going to be installed or that are already installed on the project, as it will compromise the integrity of the water stop system. Also, another safety tip. When heat welding PVC water stop, you should not position yourself directly above the iron where fumes can easily be inhaled. Inhalation of melted PVC fumes can cause irritation to the nose and throat. Green streak welding irons are supplied with a Teflon cover to prevent melted material from sticking to the face of the iron. After each weld, wipe the face of the covered iron with a rag to eliminate any buildup of PVC, which could prevent proper bonding of subsequent welds. The Teflon cover should be replaced if it becomes torn, loses adhesion with the iron, or starts to degrade in performance, which will occur after performing numerous welds. When replacing the Teflon cover on the welding iron, it adheres best when applied while the iron is hot. The old Teflon cover is also easily removed when the iron is hot as well. Use caution when changing Teflon covers and handling a hot welding iron. Additional covers can be purchased from the same source from which the Green Streak water stop and irons are purchased.